I'm sure all of you are doing great. Now in the last session we had a quite elaborated discussion regarding the projection of planes. Now let us try to improve our graphics knowledge and skill before we move on to the oblique condition of the plane with a simple problem by understanding how we proceed for the given condition of the problem. Now it's a very simple problem with only one inclination. Now it is said that a pentagon of sides 25 mm. Now even though it is not mentioned until and unless specifically mentioned, all the planes what we will be considering will be regular planes, right? If it is a pentagon, it will be a regular pentagon. If it is a hexagon, it will be a regular hexagon. We are not going beyond these numbers. So either it will be a square, rectangle, triangle, pentagon or a hexagon. Then we will see and a circular disc or circles. Because we can combine all these shapes together and we can get whatever shape we want. So that is why these basic regular shapes are understood for getting the projection, right? So anyway, so the problem, it is stating that there is a pentagon of sides 25 mm, right? Let us go through the data first. With sides or edges 25 mm, has one of its edges means the sides of the polygon. Now it is saying that one of its edges on ground. Now ground means what? Now we have seen in the first angle, ground means the horizontal plane. That means one edge is on HP, right? So we'll write it when we are writing the data. So let us understand, right? So one edge is on the ground. The surface of the pentagon is inclined at 40 degrees to HP. HP means again it comes out to be the ground. So we have to draw its projections. Projection means I have to draw its front view and top view. Now until and unless it is mentioned, I will not go for the profile view or the third view. So let us first, by understanding the problem, we will write the data, and it will be always safer which plane we are drawing. So the given plane to us is a pentagon, right? The given plane given to us is a pentagon. The side lengths or edges is given to me as 25 millimeters, right? The surface of the pentagon is inclined at 40 degrees to HP. Inclination with HP, it is called as theta, we have seen. So this theta is given to me as 40 degrees and we have to draw the projections. Now looking into the data, when it is said that it is a pentagon of sides 25, that means we know the true shape of the pentagon, because all sides it is a regular pentagon and all sides are 25. So that means I can draw the true shape of the plane, right? Now let us first talk about the condition. Now it is said that one of the edges, so this is a pentagon, though it does not look a regular pentagon, but assuming this to be a regular pentagon, let us say. So a pentagon is having 5 sides, right? And in the problem it is mentioned that one of the sides is on the ground. Let us say my palm is the ground. So one of the sides is on the ground. So I can keep it anyway, whichever way it is possible. Now to start with the problem, when we see that a particular plane is making contact with a particular principal plane or a reference plane, what we will do, see, it is said that one edge is on the ground or HP. So to initiate, what we will do is, we will keep all the edges on the HP, right? Now, why we are doing so? Because again, if you see the data, it is said that the surface is inclined at 40 degrees to ground. Now, inclination with ground will be visible only in the front view, right? and to draw this inclination I need the trace of the plane. Fine. That means I have to ensure that whatever plane under consideration is, it must be made perpendicular to VP so that I am able to see that as a line and I can give it the theta inclination. Fine. So by this also I can make a judgment that I'll have to, in the first step, make the plane parallel to HP. Fine. So this is the second way of interpreting what I have to draw. Or a simplest condition or simplest way of interpreting is, as I have said, I have been told that one edge is on HP. So first thing first, I keep all the edges, all the 5 edges on HP. Now the moment I keep all the edges on HP, that means the plate is parallel to HP. As simple as that. That means in the top view, I'll be able to see the true shape of the plane, and in the front view, I'll be able to see the trace length. Right? So this is for sure. So if this is the reference line XY, now here again we will need to develop an understanding. Now I have to, this is for sure that I have to draw a pentagon in the top view. So here in the top view, so in the top view I need to draw the pentagon. Now my point is whether it should be this way, or which way I have to draw it, because I am not able to make out in what orientation I should keep it. Right? So try to understand this situation. We are sure that we have to draw the pentagon in the top view, but we don't know how I should keep it on the horizontal plane. Right? So for that, I will take help of this information where it is said that one edge is on HP. So condition, one of the constraints or condition given to me, I will be always writing this condition as star mark, one edge on HP. This is the condition given to me, right? So that means we have to ensure when we are giving this theta inclination to the pentagonal plate, one edge must stay on the ground. So say if it is this way. So now I have 5 options. I can keep this edge on the ground and give the inclination this way. I can keep this edge on the ground and give the inclination this way. I can keep this edge on the ground and give the inclination this way. Or I can keep this edge on the ground and give the inclination this way. But the thing is, I have to ensure that I am able to as well draw this inclination. Right? Now see, very simple. If I keep it this way and I give the inclination, now in this condition you are not able to see this trace, isn't it? Fine. So it becomes difficult because I am giving the inclination, I am rotating this plate, entire plate about this edge. So that means when I am drawing that inclination, I have to draw or mark that inclination with reference to a point. Are you getting my? See, if I ask you to draw an inclination, say draw 2 lines inclined at 30 degrees. So you need, fine, you have the first line. Now you need a reference point about which you are going to mark that inclination. 30 degree or 40 degree, whatever. Right? So that means when I am rotating this plane about an edge, so I will have to give the inclination or draw the inclination also about that edge. And I can draw this inclination until and unless I have a reference point. But here the reference is an edge. But we do have the knowledge of graphics. We know that if I keep a line perpendicular to one plane, it will be a point image. So my job is done. So I can keep that edge about which I am giving the inclination perpendicular to the other plane, so that I can, when I am rotating that edge, I am able to see that edge as a point in the corresponding view, and as well I am able to draw. Fine. So whenever we find this condition, when one edge is parallel to a plane or one edge is on a reference plane, we will always keep one of the edges of the given polygon perpendicular to the xy line wherever we are drawing the true shape. Now in this problem, we have to draw the true shape in the top view. So when we are drawing this pentagon in the top view, we will keep one side of the pentagon perpendicular to the xy line. So how do we do it? So first, we will draw one projector perpendicular to the xy. Fine. So now we will see, or we will draw one side of the pentagon on this projector. Now that this length is given to me as 25, so I will mark this length 25. Fine. And to draw a pentagon, we can either, I draw two lines from these ends inclined at 108 degrees, this as 108 degrees. Take this length in compass and we mark it. So this length in compass and mark it. So these are the two sides. Then the same length in the compass, one arc, same length in the compass, the other arc. So when we join all these 5 points together, we get the required pentagon, right? Or otherwise, if I want to draw for a pentagon, the opposite corner, this opposite corner is 1.5 times the side length. So I can mark the, graphically if I want to locate this corner, I can mark the midpoint. So 1, then 0.5 in the compass and I mark it. So this becomes 1.5. Then we take this side length in compass, this as center we draw an arc, the same side in compass, this end we cut this arc, so we get these two sides. And similarly, side length in compass, I draw one arc, this side length in compass, we cut that arc. So I get the required pentagon. These are the two methods. Whichever you feel comfortable, you can use it. So we have drawn the true shape according to the required condition when it is one edge is on HP. So we have drawn, so we get the top view of this pentagon as the true shape. So when we have drawn the true shape in the top view, that means definitely the front view will be a trace length. Now what did I say? We have been told that one edge is on HP. So we have put all the edges on HP. So that means the front view will be a trace length and it will be on the ground only. Ground means on the XY. Let us see. So we'll name these corners as A, B, C, D and E. Right? So when it is on the ground, so I'll be able to see the trace on the ground or the XY line. So the trace is the extreme of the, so we draw one projector through D. So you can see that this comes out to be the trace of the given pentagon. So let us name the corners. A, so for front view we are looking at in this direction, so A first, B then, so this is A dash, B dash, this is D dash. Now there are two corners. Now when it is a regular pentagon, when you draw the projector of E, it will coincide with C, and somewhere here on the trace we will get the corners E and C. See, E first, so E dash and then C dash. Now as E and C, EC is not a side, they are two different corners, so I'll separate them by a comma. Right, so this will give me the front view. So what we did, so we placed the pentagonal plate on the ground. Now keeping this edge or the side AB on the ground, we lift the corner D so that the surface gets inclined at 40 degrees. Now when we are doing so, we are not changing its relation with VP, right? So when we are giving this inclination, the trace length is not going to change, only its orientation is going to change. Now in case of projection of planes, we don't superimpose the images in the same figure, rather we move ahead. So we separately draw the second condition. So here we have initialized the problem, or this is the initial step. Now we will put the first condition. Now here there is only one condition, so we will be putting only one condition. In case of oblique, there will be a second condition. Then in the third step, we are going to put the second condition. So from here, at a comfortable distance, again I will mark one point. So I am putting the first condition. So I will name this as A1 dash B1 dash. Now this distance can be any, a comfortable distance, say 1.5 centimeter or so. Right? Now why A1 dash B1 dash on the ground? Because we have been told that AB is on the ground. So only when the corner E is lifted, AB is still remaining on the ground. So it's coming next in view also, AB is going to stay on the ground only, right? So that means as if we are holding this corner D and simply lifting the plate. So it is coming out this way and AB remaining on the ground. So this is the first step, A1 dash B1 dash. How much we have to lift? So that this surface makes an inclination 40 degrees. So what I can do is I can draw one construction line from A1 dash B1 dash inclined at 40 degrees. So this is theta, which is given to me as 40 degrees. Now when we did so, the trace length is not going to change. So the trace length is going to remain the same. So I can take this distance in my compass, length of the trace in my compass, A1 as center, and I simply cut this. So this will give me D1 dash. Now as I have lifted D, so E and C are also getting lifted, but the length of the trace is not going to change, so that distance is also going to remain same. So I will take this distance in my compass for E and C because my reference is A1 B1, A1 B1 as center, and I mark it. So I get this point as E1 dash comma C1 dash. So I get the condition of the trace as this. So we have put the first condition, and now we will drop the projectors for the top view. So in this condition, now we will drop the projectors from A, B, C, D and E. So we will drop the projectors for A, B, C and D. Now when we have given this inclination, we have not changed its relation with VP. So all the corners will remain at the same distance from VP. Right? Now there might be one question in your mind that from XY, how far I should draw this regular pentagon or the true shape. Now it can be any comfortable distance if nothing is specifically mentioned. Now if it is mentioned that the nearest corner should be 20 mm from VP or so, then you have that constraint. Otherwise, we will be drawing this true shape at a comfortable distance from VP. So, but wherever we place it, that will be the final position. So, when we have given this first condition, all the corners are remaining at the same distance from VP, so they are not going to change. That means I can simply drag the loci of all these corners for the second view. So I can draw the locus of A, B, C and D. Right? So, and D. D is. So now we can locate all the corners for this condition. So, projector of A, locus of A must be A1. Projector of B, locus of B is B1. Projector of C, locus of C is C1. Projector of D, locus of D is D1. Projector of E and locus of E is E1. So now when we join all these corners together, A to B, B to C, C to D, D to E, and E to A. So if you have a look at this correspondingly, as if my drawing is not to the scale, but when you draw it to the scale, you will literally be able to see that effect as if this plate is lifted up. So here we will be getting this image as a projected image. Now this problem we have seen, which is having only one condition, right? So likewise then, when we are solving the problems for oblique conditions, so step by step, so like the first condition is given, so we will put the first condition, we will get the result of the first condition, and then we put the second condition in the final projection of the first step, and then we give the second condition and we get ultimately the final projection. So that is how we will go for a problem. Now in this problem, we have been said that this is theta. Now there can be a problem where it is said that maybe a hexagonal plate has one of its edges in VP and it is inclined at some certain degrees to VP. So I will be able to see the trace in the top view. So I will start with the U shape in the front view, trace in the top view, give the first inclination, and I get the final projection. So likewise. So I hope you are able to make out with this example, and in the coming session then we will discuss the oblique condition of the line. So that's all for this session.